Hi, welcome to S Mathematics. In this video, we will see basis and dimension part 6. Here we are going to see the problems. In part 5, we have seen problems whether the given set is forming a basis or not. Here we are going to see how to find out the basis and dimension of a given vector space. Now, okay, can we proceed? Okay. Now see, V is the vector space generated by the polynomials x cube plus 2x square minus 2x plus 1, x cube plus 3x square minus x plus 4, and gamma is 2x cube plus x square minus 7x minus 7. Find a basis of V and its dimension. Now see here, what is V here? V is generated by the polynomials. If you observe the polynomials alpha, beta, gamma, they are the third degree polynomials, 3 are. Now that means V, you can assume V is the set of all polynomials f of x, where it is generated by alpha, beta, gamma. Is it or not? Now, it is set of polynomials. Now, this set of polynomials you have seen. Now, if the f of x is a polynomial, a set of polynomials of nth degree, its basis will be 1x, x square and so on x power n. You have seen one problem. Show that the set 1x, x square and so on x power n will form a basis of the vector space f of x, where f of x is a polynomial set consisting of x power n plus x power n minus 1 plus so on plus x plus 1. The coefficients may be there, a0, a1 and so on, an. Okay, this is the polynomial set. Now, here also what we are going to see is, now how to write the polynomial. Now see, this is you are going to find out the basis of a polynomial vector space which consists of polynomials. Since it is generated by alpha, beta, gamma, you can take the coordinates of alpha. What are the coordinates of alpha? See, alpha is x cube plus 2x square minus 2x plus 1. That you can write it as 1, 2, minus 2, 1. Now is it clear? Quotient of x cube is 1, quotient of x square is 2, quotient of x is minus 2 and 1 is the constant. These are the coordinates of alpha. Now similarly beta, 1, 3, minus 1, 4, gamma, 2, 1, minus 7, minus 7. Now take these three as the vectors and write them in the form of a matrix. Let A is equal to 1, 2, minus 2, 1, 1, 3, minus 1, 4, 2, 1, minus 7, minus 7. Now take A and try to reduce it echelon form. So in order to reduce it to echelon form, what you have to do? Take the first row, multiply with minus 1 and add to the second row. Similarly, take the first row, multiply with minus 2 and add to the second row. Why I have taken minus 1 and minus 2? Because the first element in the second row is 1. If you add to that element minus 1, it will be 0. First element is here 1. 1 is multiplied with minus 1 and added to the 1. Then it will become 0. Similarly, 1 into minus 2 plus 2 will become 0. So, by observing these two elements, you can choose by which you have to multiply the first row. So, you have taken and you have multiplied first row with minus 1 and added to the second row. You have multiplied the first row with minus 2 and added to the second row. Your main idea is to make these two elements as zeros. So you have done like this and you got this 1, 2, minus 2, 1, 0, 1, 1, 3, 0, minus 3, minus 3, 9. Now after operating the row operations, you got that. Now observe the matrix carefully. Now you have to make this element as 0. In order to make this element 0, you should not disturb this element, the 0 which is existing already. Okay. So for that, take second row. If you take the first row, operating row, then this 0 will be disturbed. So you should not take first row, you have to take the second row. Take second row, multiply with the 3 and add to the third row. All the elements are becoming 0. So the rank of the matrix is becoming 2. That is, the rank of the matrix is the number of non-zero rows. The number of non-zero rows will be the basis set for V, and the number of elements in that set will be the dimension. Now see here, the number of non-zero rows 1, 2, minus 2, 1, 0, 1, 1, 3. Those two form a basis for V, and the number of elements in that basis set will be dimension. Now is it clear how to find out the basis and dimension for a given vector space which is generated by the given set? The given set is given as a polynomial set. It is a set of polynomials. So you have written the polynomials as coordinate system. In its coordinate system, you have converted them as a vectors, and you have taken the given vectors as a matrix in matrix notation, and you reduce the given matrix to echelon form, and from the echelon form the number of non-zero rows will form a basis, and the number of elements in that basis set will be dimension. Okay. Now see the next one. W is the subspace of V4 of R generated by the vectors. Find a basis of W and its dimension. What is W? W is the subspace of V4 of R. That means W is having its vectors which consists of 4 components, is it? Because it is the subspace of V4, and it is generated by 3 vectors it is given. You have to find the basis of W and dimension. So write the given 3 vectors in matrix form. The given 3 vectors are these: 1, minus 2, 5, minus 3, 2, 3, 1, minus 4, 3, 8, minus 3, minus 5. Take the given set of vectors and write it in a matrix form, each row as one vector. You have written, and try to reduce it into echelon form. In order to reduce it into echelon form, first accept the first element of the first column, try all the other elements to become 0. That means you have to make this as 0, this as 0. So first row is multiplied with minus 2 and added to the second row. First row is multiplied with minus 3 and added to the third row. If you do that, you got like this: 1, minus 2, 5, 3 as it is, it will remain. And this is second row is 0, 7, minus 2, 9, 2. See how you got 1 into 2, minus 2. Minus 2 plus 2, 0. Is it? Minus 2 into minus 2, 4. 4 plus 3, 7. 5 into minus 2, minus 10. Minus 10 plus 1, minus 9. Minus 3 into minus 2, 6. 6 minus 4 is 2, like that. This like that, this is also you got 0, 14, minus 18, 4. How you got it? First row is multiplied with minus 3 and it is added to this. That is the notation here we used. That means R2 here will be obtained by subtracting 2R1 from R2. That is the thing you have done. Now again, you have to make this element as 0. Now in order to make that element as 0, you should not disturb already existing 0. So take the second row, multiply with 2, minus 2 and add to the third row. First row as it is you will write, and second row also you will write as it is. Now coming to the third row, second row 2 into 0, 0 plus 0, 0, minus 2 into 7, minus 14 plus 14, plus 18 minus 18, minus 4 plus 4. So all the elements in the last row are becoming 0. The number of non-zero rows will be the basis of the W. So 1, minus 2, minus 5, minus 3, 0, 7, minus 9, 2 form a basis. Dimension of W is equal to 2. Okay. Now the number of elements in the basis set will be 2. Now is it clear? Now see the next problem. Let W1 and W2 be two subspaces of R4 given by W1 is ABCD, this ABCD should satisfy this equation. B minus 2C plus D is equal to 0. Similarly, W2 is ABCD, A should be equal to D, B is equal to 2C. Find the basis and dimension of W1, W2 and also W1 intersection W2, and hence find the dimension of W1 plus W2. Okay. Now see first. First we will try to find out the dimension of W1 and dimension of W2, then dimension of W1 intersection W2, and then we will find dimension of W1 plus W2. Now see here. Given that W1 is equal to ABCD such that let alpha belongs to W1. Then alpha is equal to, if we take ABCD, then B minus 2C plus D is equal to 0 implies B is equal to 2C minus D. That means now here you have taken alpha ABCD. From this equation you are able to find out the value of B in terms of C and D. So instead of 4 constants you are making them into 3. Is it? A 2C minus D C D. And what are the things? See here, A 2C minus D C D. This I will write it as A into 1 0 0 0 plus C into 0 2 1 0 plus D into 0 minus 1 0 1. See, how you are able to write it? By observing this. Now see here, if you take the first component is A, 1 into A, 0 0. So 3 brackets, A into first, C into second bracket plus D into third bracket, because you are having 3 constants here. First one is 0. Next one, 2C minus D. So this is second component. So second component in first term should be 0. Here it is 2C, and in third one it should be D. Similarly, the third component, this is third component means this is C and here it is 0. This is fourth component, here 0, 0, there D. Okay, you can write that like this. Therefore, if you take the coefficients of A 1 0 0 0, 0 2 1 0, 0 minus 1 0 1 form the basis of W1. Dimension of W1 is equal to 3. Now is it clear? Dimension of W1 is equal to 3. Now see the next one. Beta belongs to W2. Beta is equal to ABCD. A is equal to D, B is equal to 2C. Substitute those values here. Keep A as it is and B is equal to 2C, C as it is and D is equal to A. So how many variables you got here? Only 2. So this you can write it as A into 1 0 0 1 plus C into 0 2 1 0. Okay. Now you got like this. This by observing this you can write like this. Okay. Now take the coefficient of A and C. Those two together form a basis of W2. That is linearly independent set. Okay. So dimension of W2 is equal to 2. Now let gamma belongs to W1 intersection W2. Now W1 intersection W2 means all the elements both are in common. Gamma is equal to ABCD. B minus 2C plus D is equal to 0. A is equal to D. B is equal to 2C. D is equal to 0. A is equal to 0. B minus 2C plus D is equal. Therefore, this element will be, from here, see, B is equal to 2C. If you substitute here, B is equal to 2C, D is equal to 0. And this one. Now, 0, 2C, C0 is equal to 0. 0, 2, 1, 0 form a basis. Therefore, W1 intersection W2 is equal to dimension is 1. Therefore, dimension of W1 plus W2 is dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. That is 3 plus 2 minus 1, which is equal to 4. Okay. Now is it clear? Now see the next one. V is the vector space of polynomials over R. W1 and W2 are the subspaces generated by x cube plus x square minus 1, x cube plus 2x square plus 3x, 2x cube plus 3x square plus 3x minus 1, and x cube plus 2x square plus 2x minus 2. That means it is generated by this was generator of W1 and this was generator of W2. Okay, now respectively find dimension of W1 plus W2 and dimension of W1 intersection W2. Now see here, W1 and W2 be two subspaces of R4. They are generated by, here I have written the coordinates of the vectors. What is the first one? It is W1 is generated by this set of polynomials. The coordinates of first polynomial is 1, 1, 0, minus 1. X coefficient is not there, therefore you have to take. So 1, 1, 0, minus 1. Next, the coordinates of the second one, 1, 2, 3, 0. The coordinates of the third one, 2, 3, 3, minus 1. Now this is the generator of W1 and this is the generator of W2. 1, 2, 2, minus 2, 2, 3, 2, minus 3, 1, 3, 4, minus 3. Okay. Now you have to find the dimension of W1, dimension of W2, dimension of W1 plus W2, dimension of W1 intersection W2. See how we did. Now take the set S1 and write it in a matrix form, and after writing it in the matrix form, reduce it to echelon form. See here, 1, 1, 0, minus 1, 1, 2, 3, 0, 2, 3, 3, minus 1. Now R1 is multiplied with minus 1 and added to the first one, second row. R1 is multiplied with minus 2 and added to the second row. Then you got it like this. After that, without disturbing this 0, you have to make this as 0. If you try to make this as 0, all are becoming zeros. So second row is multiplied with minus 1 and added to the third row. So the last row became 0. The number of non-zero rows will form the basis, that is 1, 1, 0, minus 1, 0, 1, 3, 1 will form the basis. And the number of elements in the basis set will be dimension. So what you got, dimension of W1 is equal to 2. Is it? Similarly, see, dimension of W2. Now that is the generating set. You can take the generating set of W2. This is the generating set. 1, 2, minus 2, 2, 3, 2, minus 3, 1, 3, 4, minus 3. Write it as a matrix, and that is this one. 1, 2, 2, minus 2, 2, 3, 2, minus 3, 1, 3, 4, minus 3. Now try to reduce it into echelon form. In order to reduce it into echelon form, first you have to make these two elements as 0, 2 and 1. For that, take first row and multiply with minus 2 and add it to the second row. First row is multiplied with minus 1 and added to the first row. Then you got like this. After that, second row, without disturbing this 0, you have to make this 1 0. So in order to, if you try to make this 0, automatically all these elements are becoming 0 in these problems. But always it won't be true. Okay. Now take this row and multiply with 1 and add it to the third row. So you got like this. So the number of non-zero rows, these are the 2, and the non-zero rows will be the basis. So 1, 2, 2, minus 2, 0, minus 1, minus 2, 1 form a basis of W2, and the number of elements are 2. Therefore, dimension of W2 is equal to 2. After that, what you have to find? Still, you have to find dimension of W1 intersection W2. Is it? Dimension of W1 intersection W2 is equal to, now take all the elements in the first set and second set and write it. Okay. Now if you reduce it to echelon form, you will get like this. That means take first row and try to make this element 0, this element 0, this element 0, this element 0. For that, multiply the first row with minus 1 and add to the second row. first row with minus 2 and add to the third row, again first row with minus 1 and add to the fourth row, and first row with minus 2 and add to the fifth row, and first row with minus 1 and add to the sixth row. If you do, you got like this. Okay. Now again take the second row and multiply with minus 1 and add to the third row. Then you got all these elements zeros. Okay. Like that, if you take fourth row, this row, and multiply with minus 1 and add to this, then you can make this zeros. Now see, you got like this. After that, you have to write the row which is having the number of zeros more in the last. Okay. Now see, arranging those rows like this, that is first row as it is, second row as it is, and third row there all the zeros are there. You are writing in the last row and last row elements in the third row. Now here again you have taken R3. Without disturbing these zeros, you have to make this one 0. So for that, take R3, multiply with minus 1 and add to this. That means you will get R3 is multiplied with minus 1 and add. After that, you will get this one. See here. Okay. Now try to do on your own here. Now all these are becoming zeros, and now see here, if you take this with minus 1 and add to this row will become 0. After that, if you multiply this with minus 2 and add to this row will become 0. Totally 3 rows will become 0. Only you are meaning with 3 rows. Those 3 non-row elements, this is 1 1 0 minus 1, 1 0 1 3 1, 0 0 1 2 form a basis of W1 plus W2. Okay. So therefore, dimension of W1 intersection W2 is dimension of W1 plus dimension of W2 minus dimension of W1 plus W2. You got dimension of W1 as 2, W2 as 2, and dimension of W1 plus W3 is 3. Therefore, dimension of W1 intersection W2 is equal to 1. Here you have applied the theorem, is it? Now here this is what is this? W1 plus W2. All the elements in W1 and all the elements in W2. Okay. Now see the next problem. With this we will complete. Thank you.